Okay, so to do any redox reaction, you need this sheet, and the top of the sheet are the most reactive metals, and the bottom are the least reactive. And so the most reactive metals, there are no pure metals of these on Earth because they're so reactive that they're either ions or compounds. And so the only way to get them pure is by electrometallurgy, which is sending an electric current through the molecule and separating them. These are not as reactive, but the second most reactive set. And you can use hydro or pyrometallurgy to separate these. Pyrometallurgy was invented before hydrometallurgy and was more commonly used. And then these are the least reactive metals, and so they don't react at all. But to do a redox reaction, you will have say two metals, let's say zinc and lithium, and if zinc has an NO3 or a Cl, then it will want to give it up to lithium because it is least reactive, and lithium is more reactive. So if that is ever set up, then lithium will, in the final product, have the NO3. So this is what that will look like. It's the top one. You see lithium plus ZnNO3. So now try and figure out how it would be written, and I'll write it down. Okay, so here's the answer. It would be LiNO3 plus Zn, and then you'd want to go through, for Mr. Worsley's test, you'd want to go through and add charges. So Li, since it's by itself, it's only one capital letter, as a 0 charge. And then you just want to go over the Zn on the other side and put a 0 over there. Zinc, if you look on your sheet, would be +2. So you put +2 on the left side because it's with the NO3. And lithium would be +1. And then the NO3 would have a -2 charge, and then it would have a -2 charge on this side. Alright, now the next thing I have on here is LiNO3 plus K. Now, I want you to figure out if this will react or if it will not react. Okay? Okay. So the answer for that is no reaction, because lithium is more reactive than potassium. And so since potassium wants to be alone, since it's less reactive than lithium, lithium will keep the NO3, so that will not react. So you have to put no reaction or will not react on the test so you don't get off points. Next thing we're going to do is half reactions. So lithium and KNO3, think to yourself which one would be oxidized and which one, or not lithium NO3, not lithium and potassium, do lithium and zinc. So which one would be being oxidized and which one would be being reduced. Okay? And so write the beginning of each equation. Okay, so you should have Li 0 and Zn plus 2. And so just from this, you can tell which one is being oxidized and which one is being reduced. Lithium is being oxidized and Zn is being reduced. And so now finish off the equation. Half reactions are only one element. So to finish off, you copy lithium from the other side, exactly how it is. But since it's lithium plus 1, and the other side is lithium 0, it's not balanced. So you have to add 1 electron to that side, making the half reaction even. Zinc, since it turns out to be Zn0, but since zinc is 0 and Zn plus 2, you need to add 2 electrons to this side, making it even. The way I always figure it out, if you don't know which one is being oxidized and being reduced, if there is more writing on this side, it is being oxidized, and if there's more on this side, it's being reduced. Now this is going to be a bonus question on her test, which is the oxidizing agent and which is the reducing agent. It is the opposite. So Zn plus 2 would be the oxidizing agent even though it is being reduced, and Li0 would be the reducing agent even though it is the one being oxidized. So then for her test, you're going to need to do charges, like I said. And you're also going to need to balance it. So back up at the top, the first one you did, lithium and NO3. Wait, hold on. Let me get a good problem out. Scratch that. So you have the problem AgNO3 plus Zn and then an arrow. So first tell me if that would react or not. Alright, so that'll react. So then next you want to fill in the other side, and that will be Ag plus Zn NO3. And the reason that is because silver is less reactive than zinc, and so since zinc is more reactive, it'll take the NO3 away from silver. So then what you want to do next is you want to put the charges in. Silver, since it's with the NO3, is going to be +1. NO3 is going to be -1. Zinc is going to be neutral or 0. Then you go over to the next side. That's silver is going to be 0. Zinc is going to be +2. And NO3, you're going to need 2 of them because it's -1 on the left side, so it stays -1 on the right side. So you're going to need 2 to balance out the zinc. Now, put that in a half reaction. So we're going to start out with silver. You have Ag plus, and then an arrow to Ag0. And then what you're going to do next is this oxidized or being reduced. So then you add the 1 electron you need to the right side and make that even. It should look like that. Then you're going to do zinc. You have Zn0, arrow, and then Zn plus 2. Then how many electrons are you going to add? And it's balanced with a plus 2e. Now, the trick here is if you have one that is a minus, so you have, say, Cl0 on the left side, an arrow, and then Cl -2 on the right, you can't just always assume that the electrons are going to be on the right side if there is this neutral element on the left side, because -2 and then if you add 2 electrons, -4, the algebra does not match up. So you have to balance it out. You have to put the 2 electrons on the left side, making it -2. So then it'll be balanced. That's really it. Just make sure you balance the equation so it's even. So if there's 2 zinc on one side and 1 zinc on the other, put a 2 in front of it to make it even, and then make sure that all the other things aren't affected by it. Though the other thing is, to make sure it's not a redox reaction, is if nothing changes. So if you have an equation that's balanced, or it's the same exact charges on each side, then that's not a redox reaction because nothing changed. At least one thing has to change in order for it to be a redox reaction, so she might put one of those things on the test. But yeah, I hope this helped, and if you have any more questions, I can help you answer them.